Welcome back everyone to part 8, where we had a look at subselect, inline views, derived tables, etc. And in the first part we had a real good dive into the subselect when it's contained within the join itself. Now, before we move on to the next lesson, let's go over the answers from the previous video. The scenario was that the warehouse manager in Lords had arrived from out of town and he was asked to take some days of leave. However, he didn't want to leave his staff hanging with all these orders to fulfill without his guidance. So he's come to you for some data to find out which customers have outstanding orders. So these were the columns he was after: customer name, total quantity of items ordered, items shipped, and at the end total outstanding, which is ordered minus shipped. So we've got one column from it, it's pulled directly from the table here, which is going to be our customers table, and then we've got some totals here, so some sums going on, some group buys, and we need to bring those in on a subselect. Easily enough, we were making sure it was all unshipped orders in 2016, so there was a little bit of filtering going on there. Let's check my answer. If you had a go and you've got something along these lines, brilliant stuff. If not, we'll go through it quickly so you can understand exactly what's going on. So, customers, as mentioned, and we get our customer name from that table there, pseudonymized as C. Then, in our subselect, we had to somehow link our entire subselect table that's been generated onto the customers table, and we're going to be using the customer ID, and that can be gained from the orders table itself. So we're bringing in the orders table mainly as well because we needed unshipped orders in 2016, so we needed to make sure that we filtered the orders table by 2016 so that we include all orders in 2016 as a baseline going forward. Once we've got that, we can then bring in our customer ID as our joining criteria. As you can see here, we've called our subselect A, and we're joining customer ID to customer ID on the customers table itself. Brilliant stuff. So we were then asked to provide the total amount of items ordered, total amount of items shipped. So ordered, we know that quantities actually come from the order lines table, so we're going to be joining that one using the order ID, and then we just simply take the quantity. Let's change the database quickly. Take the quantity from order lines, and there you have it. Here's our quantity, and that's all we've been asked for, is the quantity of items itself, nothing to do with price, so we simply fire in the quantity as you can see there, and that will be our total ordered when we sum it for every customer ID. Next, we had to bring in what was shipped, which is effectively everything that's been invoiced, and now we need to make sure once again that we do a left join on our invoices table, matching the order ID with the order ID on orders, and then left join the invoice lines. And the reason we're left joining is of course that some orders haven't been shipped yet, so we still need to pull the quantity correctly from order lines, so any that haven't been shipped will come up as null and won't return any rows to tally up at the end. So we made sure we left joined on our invoices and invoice lines. Now we're going to get all the customer order IDs from the orders table, customer orders there. We're filtering it by the year as 2016, and we know that order lines inner joins onto orders, and we pull our quantity. So we've got our total ordered. We then of course have to left join onto our invoices, and again joining our invoice lines onto our invoices, and that will give us our quantity shipped there. Let's have a look at that table, and there you have the quantity there. So we're getting all the figures. We're going to sum everything up, group by the customer ID. Let's have a look at that. Quickly execute that table, and as you can see, here's our customer ID, total ordered, total invoiced. Some of them are slightly different, and that's because some have not been shipped yet, but if we had inner joined, we would get matching values across both if we had inner joined with the invoices table. So that's why we left joined, to incorporate any unshipped orders to the customer alongside the orders themselves. So we join on customer ID, customers table, and the next trick of course is to simply focusing first on customers' largest amount of outstanding orders. So what we can do, and don't worry if you missed this trick out here, what we can do is we can say where the total invoiced from our table here, our subselect, is less than the total ordered. So that means that for every order we only want to see the ones where there is an outstanding amount of orders. And up here you can see the mathematical equation, simply taking total ordered minus total invoice to get our total outstanding. All we're saying here is if our invoice number is less than our ordered number, then let's include it in the result set. If not, we'll ignore it. So if we did ignore that where clause on the outside, which is probably maybe what you got on your select itself, as you can see there's a lot of total outstanding of 0, 663 rows, but at the end of the day we don't really want to see those. What the warehouse manager wants to see is anything outstanding, because then he can focus on those and not worry about things where it is 0. Another way we can do that is simply to say where this bit here is greater than 0. So you may have put that in like that and you get the same results going forward. So only total outstanding where it's greater than 0, and that's 405 rows. So don't worry too much if you didn't put that where clause in. Same as to clear as many outstanding orders as possible. At the end of the day, if you return a result set like this with total outstanding orders of 0, I'm sure you could have filtered those up and ignored them. You can also, if you wanted to, do an order by and showing the most amount of outstanding orders at the top, and then ordering by, ordering down the list. So just simply, you can actually put a mathematical formula in your order by clause, going from the highest number first, then going down. Let's have a look at that. And as you can see, total outstanding 750, and it starts to descend as you go down the list. So that's a few other little tricks that you can use just to make sure you get the right data going back. So how did you do on that one? Main thing to focus on, obviously, is the subselect, getting that subselect right, returning your values on the outer part of the query here, and maybe, if you remember from the previous lesson, a little mathematical formula to get the total outstanding. Fantastic stuff. Let's move on to the lesson itself. So what we're going to cover now is the same thing, the inline views or derived tables, subselect, but this time it's within the actual select statement itself. As you can see here, it's within the column. So we've got a comma, then we want to put a column in that value in that column, and then we're going to name the column there. Now this one is without joins. It's a simpler version. Basically all we're trying to do is return one single value. Take that there. It's not Control 3, we execute that, and we've got that one single value there. So what we're going to be doing with that is putting that in against every row in our table, and we're going to be naming it total of all order quantity. As you can see here, we simply have just the sum of the quantity from the table, then there's no other criteria, there's no other columns being pulled, there's no filtering going on, so it's literally summing up everything in the quantity column from the order lines table and giving us the value. And down below we're doing the same thing where we've got the unit price times the quantity from sales order lines, and we're going to call that total of all order price. Let's have a look at that one. As you can see, it's quite massive, so that's everything from the table, order lines, unit price times quantity, all summed up into one value and one value alone. So putting a subselect within your select statement as one of the columns is quite a quick and easy way of putting in a value against every single line. Let's have a look when we run off that query there. As you can see, it just simply puts it against every single line down your entire list of 73,000 rows. And again, here's your total order price all the way down to the very bottom. So if you did want to put a single value in against each row, and this does happen quite regularly, this is of course another way to do it. You don't have to put it in your join, you can simply put it in your as a column instead within the select part of your select statement. Now the thing you need to know about this is it's extremely inefficient because it's running numerous select statements pretty much for every single row 73,000 times to get this one value over and over again, and then your final select statement you're bringing it all together. So that's why the subselect within the actual inner join itself is a lot more efficient and more widely used. The only time you would only really use this sort of subselect here is if you're dealing with an extremely small amount of data. So you've only got a few values, you've only got a few rows, you can just quickly bang a cheeky little subselect within the actual column itself, and it shouldn't be too bad. As it is, this query didn't take any time to run because it's a very, very simple select statement. Of course, brackets open and close around the entire subselect, and you can make this as complex as you want to pull certain values. And in this case, we only want one value. You can only put one value in the column against all rows, so we simply select one value from the table, sum everything up. So that's it, purely and simply. That's a subselect within the columns themselves. Don't forget to put your open and close bracket, and remember that it's pretty inefficient when it comes to running off the query itself. And of course this is without doing any other joins to the outer query there. Pretty straightforward. Let's have a look at this question here. The warehouse manager is keen to check current stock levels for each item versus the average stock level of every item throughout the warehouse, all in 2016. He's come for you for the information. Now, his query is a bit light on detail, but I think we know by now how we need to start building this query up. We need to show each item, the stock level of each item, and then we need to bring the average. Here's the stock level of each item, and then we bring the average stock level for every item throughout the warehouse. So let's crack on and see how we go with the query. We're going to do the subselect within the actual column itself, as we've just shown you above. So on the outside, what do we need? We need the item itself, and the item name is within the stock items table here. We're going to call that as. In fact, we don't even need to name that because we won't be joining any tables to that. And we just need the stock item name. So we've got our item now. We need to now bring in the stock levels. So in fact, yes, we do need a join. We'll go for item in a join, and the stock item holdings is the table we need for the actual stock levels. We're going to call it H stock item ID equals I stock item ID. There we have it. Let's put our pseudonym on the name there, and of course we need to bring the current stock levels. Let's see what column we need to use from this table here. Here we go, quantity on hand. Let's just bring in the quantity on hand. There you have it. So we need to make sure it's 2016 as well. So pulling back the stock item holdings table, we've got the last edited when. So we'll put in our filter. Last edited when equals 2016. Chuck in our year function there. And we've pretty much got most of our query together to provide most of the information. Now all that's left is the average every stock item throughout the warehouse. So we simply put select average, and is the stock item holdings. And this is of course the quantity on hand. So all we're doing is selecting the average quantity on hand from stock items holdings. What we'll also do is we'll chuck in this where clause here just to make sure, just in case there are any values that creep outside of our 2016 there. So that's pretty much it. Let's have a look at that, see if that works. Our little subselect, there's an H in there and there's no H here for pseudonyms, and we'll run that off quickly, execute that. As you can see, we get an average value of 133670. So we've put that in as a subselect in a column, and we're just going to call that average stock for good measure. If you don't put in a name for your column, it'll still run, but you won't get a name popping up at the top of the column. So let's run that off very quickly. Here you can see your stock name, the quantity on hand, and the average across the board. As you can see, it's no column name popping up there. Let's put that back in. And there you have your average stock. As you can see, it's the same figure the entire way down. All 227 rows, quantity on hand against the average. Brilliant stuff, very straightforward, possibly a little bit easier than to do, then a little bit less work, a lot less to consider when you compare to when you do the subselect within the join itself. All you need to remember, open brackets, close brackets, write out your select statement as normal. Doesn't matter what format you do inside here, you can do it row by row like I've done here, or all in one line as I put here, purely up to you to get that one single value. And remember, this way you need to make sure that you pull one single value. So if you decided to select the sum, quantity of hand, and then the average, I'll show you what happens. So you wanted to pull two columns here, the sum and the average to work with. What will happen is that only one expression can be specified, it's not introduced with exist, and that's because you've got two queries here, so it doesn't know which one to plonk against your outer query here. So we need to restrict it to simply one individual value within this entire statement here, which we have done. So our subselect works fine in the rest of our select statement. Pretty straightforward, very easy to understand this one, but once again, remember, if there's millions of rows and you have a pretty complex select statement, each column is having to run that select statement off multiple times, which is a very, very inefficient way of coding, because SQL is all about set based, which is where your where clause, you pretty much eliminate vast quantities of the table. Anything that's not 2016, you've eliminated it completely. However, in this methodology, you're going back to row by row querying. So that becomes very, very inefficient. Are you all happy with that? Pretty straightforward stuff. Let's have a look at the subselect outside, or should I say within the select columns, versus the one within the joins, and how the two compare. Let's have a look at it. So we'll take this example that we had at the top, where we got 73,000 rows, and we'll do the same thing below within the query itself. Now the key thing to note here is that we're simply pulling one individual value, so there is actually nothing to join on. So we can't do an inner join or even a left join subselect like we normally do. So what we're going to do instead is we're going to use our cross join, and all we're doing is pulling exactly the same code over here, except that we're going to call our sum quantity, we're going to name it within our subselect here. As you can see, it's within the brackets, whereas here we have to name it outside the brackets because we want to name the actual column itself. And of course, when we have it in our cross join or any other join, we then need to pull it up top here. So we're going to pull it over there. Whereas here it's actually as the column itself. Same thing with the next query here, which is the unit price times quantity. We're going to do another cross join, and we're going to select the sum times the quantity. Name the column there that we're going, or the value that we're going to pull from order lines, and we're going to pseudonymize it as P and pull it into our original query. And remember, with the cross join, it's going to apply that single value against every single row, so there's no join criteria there. Just like there's no join criteria here, because it's one single value. Because we're also pulling one single value there, we can cross join it and it'll add it to our select rows there. So let's have a go. That was 73,000 rows. Let's run them both off together. We'll grab a bit more screen for you. And as you can see, the results are exactly the same. If I click into this table here, 73,003 rows, click into that result set there, 73,003 rows, and the data is all the same. So that's one way. If you simply join in individual values, a cross join is actually more efficient than the subselect within the query itself. So that's one way that you can improve your query's efficiency, is to remove these from the columns, use cross joins or any other join, as we'll see in the next video. And that's pretty much it for the subselect in line with the column. Pretty simple stuff all round, putting one value and putting it against each individual row. So, keen to give that another try? If so, we'll leave you with this little scenario for you to work on in your own time, and we'll look at the answer in the next video. So the purchasing manager is after some data. She needs to see numerous purchase order details per supplier for all orders in 2016. She is also after the average quantity of items ordered from all suppliers during the same year. So it could be 2 where clauses in there, pretty similar to having a where clause there and a where clause inside your subselect. And of course, we're going to be practicing our subselects within the column itself to make sure you write your code accordingly. So these are the columns that we need to pull: the data, that's the purchase order number, the item description, order quantity, and then we have our subselect aggregate there. So give that a go, see how you go. Make sure you put the subselect in the right place, refer to the code above if you get stuck, give it a try, and we will see how you went in the next video. Everyone, until then, I wish you all a fantastic day.